Hi, this is Mrs. Slater,
and Brooke.
and this is the joke for the day.
What gets wet when drying?
The answer will be at the
So in today's lesson 2.4 and 2.6, it's all about inequalities. And the inequalities we're going to be studying are less than or equal to, greater than, and greater than or equal to. These inequalities will help us find and solve the few examples that we're going to be doing today. So before we solve the inequalities, there's just a couple things that I want to go over first. And it's when you divide by a negative. Okay? Everything is going to look like an equation until you start dividing by negative numbers. Dividing or multiplying. So let's go ahead and put or multiplying in there as well. Okay, so if you divide or multiply by a negative number, the inequality ends up flipping around by a negative number. The inequality switches. Also, the second thing is when you are graphing any type of inequality, like x is greater than 4. Okay, there are certain symbols that we're going to use for each graph. For example, here is the 4, and then if there is a greater than sign, we know that at 4, we're going to put an open dot because it's not including 4. As you know, the little bar underneath the inequality means included. And since this problem does not have the bar underneath it, that means the 4 is not included. So we're going to show that by putting an open dot. And because it's a greater than symbol, that means all values to the right will work in this particular equation. So what I mean by that is, let's look at it like 5, 6, and 7. If I took this 5 and plugged it into the equation, is it a true statement? Yes, 5 is greater than 4. So the 5 should be shaded in. Same with 6. If I said 6 in for x and 6 is greater than 4, yes, that also checks. And same with 7. 7 is also greater than 4. So you can see by showing all of this, and it includes every rational number inside of there. So there's many, many points that you can do. For the next one, when you're graphing less than or equal to, x is less than and equal to, let's say, negative 2. And you have your graph at negative 2. It's now going to be a closed dot because that bar underneath means that the number is included in the graph. Okay, so then less than represents everything smaller than the negative 2. So it's going to be everything to the left. And once again, just to show you what that means, if we take a negative 4 and plug it in for x, negative 4 is less than or equal to negative 2. The answer is a true statement, so that's why it is shaded on this side. Same thing with negative 3. It is also less than negative 2. So everything, including all the numbers in between in the space, are going to be included. Okay, so let's jump to more difficult problems. For example, 3x minus 1 is less than or equal to 2x minus 3. So we're going to solve and graph. And when you have two variables on both sides, we should get those on one side. 2x subtracted to both sides will leave us an x. And then adding 1 to both sides is going to give you x is less than or equal to a negative 2. Okay, so then the graph itself is going to be negative 2, closed dot, and then everything shaded to the left. Example 2, I want you to try is 5y is less than or equal to 3 halves. Okay, here there's only one variable, but you have a fraction that you have to deal with. So both sides you're going to want to multiply by 1/5, and that way the y will be isolated all by itself here, and then 3/10 would be your answer. So on your graph, I'm okay with you putting 3/10 underneath the graph itself. Again, close dot, and again to the left because the less than sign. Now keep in mind, when you are looking at the symbol, if the Y is on the left side, if it looks just like this, the arrow is going to be pointing in the same direction when you go to the graph. So just keep that in mind, and I'll bring that up again. All right, example 3, I want you to go ahead and push pause and try it on your own. -2y greater than 5/6. Okay, so when you are done, hopefully it looks like this. You have a -1/2 multiplied by both sides. And if you remember the rule, it said that anytime you multiply or divide by a negative number, this is going to switch. The greater than sign is now going to be a less than sign. And -5/12 would be your answer. Okay, so now on a graph, -5/12 would be underneath the tick mark with an open dot because we do not have any that is saying it's not included, and everything would be to the left because it is less than. Now if you wanted to check your answer in a situation like this, especially when you have the rule apply here, you're going to pick a number to the left, and in this case I'm just going to pick a -1. If you take the -1 and you want to check your answer here, you take the -1 and plug it in where you see a Y, and let's check to see what happens here. -2 times -3 is 3. I'm sorry, -2 times -1 is 3, and that is a true statement. That is greater than 5/6. So since it's true, look up here where we shaded. We did shade on that side, so we know that we have a correct answer. So keep that in mind when you start doing tests and quizzes. All right, let's go on to the next one. Example 4. Again, I want you to push pause and do this one on your own. It's -5y plus 17 less than or equal to 8y minus 5. Okay, so let's see how you did. I want to get the y's I want to get the y's together. -8y to both sides gives me a -13y plus 17 less than or equal to -5. And then subtracting 17 from both sides gives me a -13y less than or equal to a -22. And the next step, as you can see, we have to divide by negative. So I'm going to put a big stars there because this means we have to divide by negative to both sides, and we're going to have to flip that sign to a greater than or equal to. Okay, and it looks like there's nothing that's going to go into 22/13, so I'm just going to leave it just like that. And then my graph at 22/13 is going to be a closed dot, and it's going to be shaded to the right because it is greater than. That is supposed to be a 22/13. Okay, so once again, just do a little check to make sure we have it in the right spot. And I know that 22/13 is less than 1, so I'm going to pick like 2 to plug in. And we could plug that in to the original. Looks like I'm going to have to go up here though. -5 times 2 plus 17. And we have to find out if it's less than 8 times 2 minus 5. So -10 plus 17, 16 minus 5, and you have 7 less than or equal to 11. Is that a true statement? Yes. If you come up with a false statement, that means somewhere in the beginning of the problem you need to go back and fix what you did wrong, or it could be just the negative sign that you forgot to switch the sign on. So just be careful of that, and it's just a good way to know if you got the answer correct. Okay, so now we're going to talk about compound inequalities, which is what lesson 2.6 is all about. Okay, so in a compound inequality, it is all about The first type of compound inequality is called a conjunction, where the two statements are joined by the word and. Okay, so when you see anything joined by the word and, it is considered a compound statement, and you can write it like this. This is just an example. -2 less than x plus 2 less than 8. So when you have a compound, this means that two events are happening. So what I'm going to do here is, instead of just subtracting 2 to one side, we're going to do a -2 to every single term. Okay, so what happens, -2 and -2 make -4. The x now is all by itself, and positive 6 would be on the right side. So as you can see, we are still isolating the variable, but there's just an extra step that's going to be involved. Okay, so your final answer is going to be -4 less than x less than 6. Now if you're going to graph anything that's and, we are going to put the 6 because it's the larger number, then -4 because it's the smaller number on that side. Both of them are going to be open dots. And if you look at this individually, like for example, x less than 6. Okay, and then this one is -4 less than x. But to make it make sense, you can just flip them around, everything included, to make it sense, because x is, the greater than sign is on the x, so x is greater than -4. So what ends up happening is the 6 is going to be less than, the 4 is going to be greater than, and the only place that they intersect is in between. So on a conjunction, you're always going to see the two of them shaded in between. Okay, so that is all for that one. Now the other type is called a disjunction. And a disjunction is going to be two statements separated by the word or. Because two things, one or the other, could happen. For example, you could have x is less than or equal to -2, or x is greater than 4. Okay, when you have a problem like this on your graph, you put the smaller number first and then the larger number. The -2 has a negative or a equal sign underneath it, so we're going to shade that in. And then the 4 has a greater than, so we're going to have an open dot there. Less than means everything to the left. Greater than means everything to the right. And then we'll shade in. Okay, so I'm going to give you 8 examples on conjunction and disjunction. I'm going to have you push pause because you will have to write them out, and in class we're going to go over them so you can ask questions about them and find out how you did. So go ahead and write the following questions down and complete them before class tomorrow. Please solve and graph. Please solve and graph these as well. And here are the last two. We'll go over these at the beginning of class tomorrow. The answer to the question, what gets wet when drying, is
a towel.
And that is the end of the video. Goodbye.
Goodbye. Adios, Caminos.